Joints of the human body. Joint is the point of connection between two bones. Strands of connective tissue, ligaments, holds bones together and ensure the stability of the joint. Further, joints are classified according to their motion capabilities, such as synarthrosis, which is an immovable joint, example, sutures of the skull. The second one is amphiarthrosis, where the slight movement is possible, such as in the case of intervertebral discs. The last one can be diarthrosis, which allows the greatest amount of motion, as in the case of synovial joints. Moving on, joints are further classified by the material that joins them. The first one, fibrous joints, which allows no movement and joined by fibers. The next, the cartilaginous joints, joined by cartilages, which allows limited movement. Last is synovial joints, which allows large range of movements. The next, we move on to characteristics of synovial joint. Hyaline cartilage, joint cavity, synovial membrane, synovial fluid, capsule, and extrinsic ligament. Here we have the hyaline cartilage, also known as the articular cartilage, because it covers the articular surface of the bone or the articular bone. And this is the joint cavity. This is the joint cavity hole, which is filled with the synovial fluid. This is the synovial membrane, this dotted structure which covers the joint cavity. And this is the capsule. The whole round is the capsule, and the capsule is lined by the extrinsic ligaments which support the joint and connect the articulating bones of the joint. Now let's see what are the types of synovial joints. The first one is the hinge joint, which is uniaxial, which allows the movement in one direction, has one articulating surface that is convex and another that is concave, just as shown in the picture. For example, the humero-ulnar elbow joint and the interphalangeal joint. The second type of joint is the pivot joint. For example, the radio-ulnar joint below the elbow joint. In this, the head of the radius fit perfectly into the notch of the ulna, which is bounded by a ligament so that the radius stays in place. This ligament helps the radius to rotate, which results in the pronation and the supination. The radius twists and turns over the ulna. That means the ulna is basically still, because the hinge joint do not allow the ulna to move, but the radius only moves and it provides the uniaxial movement. And yes, don't forget that the base of the ulna and radius is also a hinge joint. The next we come to condylate joint. It is a biaxial joint which provides flexion, extension, abduction, adduction. One joint surface is an ovular convex shape and the other is a reciprocally shaped concave surface. The example we can take here is one of the metacarpophalangeal joint or the wrist joint. The next we come to saddle joint. Saddle joint is a biaxial joint. Here the bones are set together as in sitting on a horse. Example, carpometacarpal joint of the thumb. The next with us is the ball and socket joint. The ball and socket joint is a multi-axial joint. That means rotation in all planes is possible. A rounded bone is fitted into a cup-like receptacle. This simple and effective structure allows its movement in all axes. Extension, flexion, abduction, adduction, rotation, and circumduction. The hip has deep socket which gives stability but limits the range of motion, whereas the shoulder joint has a shallower socket which provides less stability but provides a greater range of motion. Maybe that is the reason why shoulder dislocation is the most common. Ouch. The last but not least, plane or the gliding joint. It is a uniaxial joint which permits gliding movements. These are basically two flat-ish surfaces placed one on top of the other which can glide or rotate one on the other. These come in groups basically in hands such as carpals and tarsals in the foot. These are bounded by the ligaments which provide some movements such as round movements. And one such example is the acromioclavicular joint, which is between the clavicle and the acromion process of the scapula.